when people are saying we don't want encryption, what they're really saying is it's okay if my data isn't kept secret or private, but they're not saying my data should not have data integrity and authenticity. And since they care about that, they need encryption because that's the way to get a guarantee of data integrity and authenticity.
All right, everyone. Welcome to the Ockam podcast. Every week, Mrinal, Glenn, and I get together to discuss technology, building products, secure by design, how Ockam works, and a lot more. We comment on industry macros, things across the cloud, open source, and security space. And eventually, we'll start bringing some guests to maybe challenge some of our dogmas. So if you have an idea or you want to join us on our podcast, let us know in the comments below. We'd love to have you on to debate some of the things that we see in the world. And that brings us to what we're going to talk about today, which is a lot of times when Mrinal and I are having discussions about what we hear on calls with customers or just what people say on other podcasts, we often try to unpack what they're actually talking about. And there are a couple topics that we think are interesting and maybe even like some memes in the security space right now and in the data space. I think it's important to unpack what some people are talking about. So we specifically want to talk about people seem to have a qualification around the importance of their data and what they should be doing with it. They usually have some sort of qualification around the privacy or security of their data, and then build some posture or governance model around that. And then they usually talk about different technologies, like whether something is encrypted or needs to be encrypted or how they're encrypting it. So I want to unpack that. And let's start with the first one, which might be the simplest, is when we hear people talk about or qualify the importance of their data, and usually it's linked to how they need to protect it, or what they need to do to secure it, or whether they're encrypting it or not. Let's dive into this, because I think that what we talk about a lot is that people think their data is far less important than it really is, and undervalue what happens when that data is used in their applications, because those applications obviously rely on that data to be truthful and to have integrity to go do things with the data. So with that, I'll kick it over to Glenn. My data is not important. Why does this not make any sense?
Yeah, it's an interesting one, isn't it? Like the initial reaction is hard to not just go, well, why are you collecting it then? Like if the data is not important, just stop doing that. Stop wasting cycles. Like to some level it is, but I think what people mean by that is something else. Like the word important is probably the wrong one there to use. It's like it's not commercially sensitive, might be an example of what they were going to say if we push them to be more specific. It's like it's just some aggregated metric stuff, or it's an environmental sort of thing that anybody could capture this data. It's not specific to us. It's kind of publicish. If someone saw that data, yeah, we don't care. Like that's often I think what people mean is just like, like we don't care if it's private is what they mean, rather than it's not important. It's just anyone can see it and we wouldn't care too much. I don't know if you had thoughts on that, Mrinal.
Yeah, an interesting kind of nuance in that is like there's the importance axis and there's the what is considered data axis. And oftentimes even like people will think about what they're collecting as data in some sort of environmental context, but they'll not think of the request to collect that data to some service as data itself, right? So it's that the importance is in the fact that I'm collecting the observing some piece of information, collecting it, and then delivering it to some place where I store it. That message that carries it from the place you collected it to the place you store it is also data that's relevant to whatever reason you're collecting that information, right? And so it's important usually to that reason of why you're collecting the information. Maybe you're building an AI model because with that information or something like that, it's important that the data is always correct when it's fed into that model. It's important because it's critical to whatever your business use case is that relies on that model.
And it's because you're building an application that is going to consume this data and make some sort of decision based on the data it has to produce some work or output. So it's the process that you have built that's going to consume the data, and the way it's going to be transformed that is the important part. Even if the data is, we're talking to someone that was collecting data at a wind farm. They claimed their data was not important because you could just stand out in the field with a little anemometer and collect the exact same data. But obviously, they're making important business decisions like turning on and off the wind farm, making forecasts on how much energy is being produced, all sorts of decisions. So the applications in the data center definitely need good information. So ergo, the data is important. And then I think that you could say, well, the data is not important because, again, it's like publicly available. Well, you've curated it, and then you're going to build some application around it. And that is also important. So I think we've dispelled that one. The data is important, and the integrity of that data is critical because your application depends on it. Okay, so the next one that we hear a lot is around privacy and the importance of privacy around data. I think this goes actually in two directions. People either over-index on it or don't index on it. And I think both are interesting to talk about. So obviously, privacy of data is a big topic right now, just in the press. There's now this SEC rule where if you have a data breach, I put this in the privacy bucket, then you need to disclose that you had this data breach publicly if you're a publicly traded company. So this entire category of privacy, let's unpack that one, Mrinal. Okay, so if someone says, my data doesn't need to be kept private, or maybe let's take this assumption that, if there's a data leak and it gets spilled out, maybe because it's just phone book data or some sort of publicly indexed data anyway, what would be the other concerns that we would have to think about when we're talking about privacy of data, even if we don't care that it leaked outside of our data center and someone maliciously stole it from us? Let's say, put that aside. What else should you be thinking about when you're thinking about privacy of data?
So let's take that case of my data doesn't need to be kept secret, right? It's okay if everybody knows that I collected some information at a certain point in time. Even if that's okay, what's usually not okay is the information I collected is incorrect, right? So going back to that previous point about importance of the data, the fact that you're putting in whatever effort you put into actually collecting that information, it is important to you that the data is correct. And if that is important to you, then the tools that go into making data have properties of data integrity are important to you. So it might be okay that the data is revealed to someone, but you probably are not okay with the data being tampered or the data not coming from the source you think it is coming from, right? So I think even when you don't care about the privacy, the secrecy, the confidentiality of a piece of information, you still care about the data integrity and authenticity of that information.
Let's break this down to a specific example. There's some application living in the internet somewhere that's producing some data, originating it. It sends it across the internet to a database that's going to store it before eventually it goes off into some application that's going to run that process. We already talked about why that's important. But just in this data producer to data store application, so what you're saying is I'm sitting there and, as a malicious application, I can see the data going past me on the internet and I can read the data. And let's presume we don't care about someone seeing the data as it's passing over the wire. We do care about the integrity and authenticity and originality of that data because what's going to happen at the database.
let's make it even more concrete, right? Let's say the message from here is write to the readings table that the observation is 500, right? That's the message that's going over the wire. And we've already decided that everybody knowing that this reading was 500 at this point in time is not secret information. We don't care about its privacy, but we still care that when that message reaches the data store, it is in fact written to the readings table and the value 500 is written to it, right? So those two pieces of information, that it's being written to the readings table and the value is 500, must remain the same from when the message started to when the message was received, right? Secondly, we also care that only the authenticated data source can say write to the readings table the value 500. Some random attacker in the middle cannot just generate random messages and generate 5,000 readings that get stored in our database, right? It will bump up our database bill. It'll create garbage in our database that will affect our model, AI model that will learn on this database. So it's just like garbage will get fed into our system, or we'll just end up spending a lot of money dealing with that data, right? Both of those would be bad. And it just doesn't even end there. The store of data will acknowledge the fact that it received the data. And so if an attacker in the middle can block that acknowledgement or incorrectly send that, like generate an acknowledgement when an actual action didn't happen, that would be bad too, right? Because if I can block the acknowledgement, the source keeps sending the same data over and over again, maybe, right? Which has the same effect. 5,000 readings get created instead of one reading because I was able to block the acknowledgement, right? Which then has the cost of more data getting stored or garbage getting stored into my database. Or I can send incorrect acknowledgements. So even though the source said store the reading 500, that reading never gets stored because the attacker in the middle sends a fake acknowledgement, right? So to sort of what this means is, even though we didn't care about the privacy of this flow of information, we still care about making sure that only this source can write to this data storage location, and only this data storage location can acknowledge the fact that the data has been successfully written, right? So we care about the authenticity of these messages and the integrity of these messages because we don't want incorrect readings to be stored or stored in the wrong table.
That's right. And to unpack that even further, or to maybe shine a spotlight on one piece of that, I described this, you're seeing the message as the person on, the application on the wire. Well, it also, if you have this in a clear text, transparent way, it also means you know how to write to the database, right? So you can then start doing man in the middle attack like things, right? Because you basically know what's happening between these two, where it came from, where it's going, what the message is, how to write to it. Like, gosh, maybe you even have a credential in there doing something in some unprotected way, right? The punchline here is privacy is not the only security concern, which brings us, Glenn, to unpacking security as a word. And people talking about security is important to us, and then how they actually go about setting up security, thinking about data governance, control of data. Do you want to talk a little bit about how the spectrum of how people think of secure systems in this kind of distributed computing world versus maybe when the simpler days when all of our applications were just running in one box?
I think there's something I wanted to touch on from Mrinal's thread there as well, which is like, I need to qualify this because I'm going to sound like a hypocrite, but I think as an industry, we don't care about privacy enough. Like the SEC ruling and these changes and things are like forcing companies to think about it. But that said, when we start thinking about security, we myopically think about privacy more often than not. And so like there's that kind of juxtaposition there of like, we're not thinking about it enough. But then when we do start to think about it, we think about it too much at the expense of the other things that Mrinal was pointing out there. And I think it was Matt Johansson, a shout out to him in his newsletter, by the way, like great resource if you're into this field, gave an example of how securities, people think of it in the context of like visiting an ER. I'm going to butcher his analogy here. You should go read it, but he made a point along the lines of like a thing that had happened and you triage it and you're done and you move on. And like what we witness time and time again is that's not the case. Attackers get in and they lay low for a long time. And so like these tiny little things escalate over time, or they'll sit there and they'll do some reconnaissance on your systems. And, thinking about it only through a privacy lens there, his point was that it's more like a mental health condition. It's something that needs constant nurturing and, essentially therapy. Like you need to maintain it and keep yourself in a healthy state. It's not something you can just triage. And I think when you think about it from the privacy perspective there, myopically, at the expense of all the other things, and with the advent of AI and all these other systems, like someone getting into your system and exposing your data is embarrassing. And that's why it's human for us to focus on privacy, because you'll get called out on it publicly, you impact a lot of people. The idea of someone getting in and just quietly polluting your data for some extended period of time is like quite terrifying to me these days. Like I think as an industry, we're a little bit asleep at the wheel on helping people understand those risks, because especially if you're feeding this into an AI model now, you're trying to train up something on all this data that you've been collecting for 2 years and making business decisions at the back of that. If you can't absolutely trust all of the inputs into that system, well, the outputs are going to be absolutely garbage. But there's this black box in the middle that's hidden you from that. We talked about the wind sensor thing before. That's a triage type problem. If you get a wind speed rating of 900 knots and you've mistakenly shut down a turbine because it can't operate at that speed, you know immediately that a mistake has been made. The wind was never at that speed and you shouldn't have shut that down, and you can triage that. If you've had someone in there polluting it, just, random variants into your data for 2 years, that data's gone. Like you can't go back and fix it. You don't know when the problem emerged. You can't clean it. Like your data is forever polluted. Your business intelligence is forever ruined. So yeah, I went off on a bit of a tangent there, but I think that's, people think about security and they've conflated it for a long time just because of the emotional attachment to privacy. And there's a much bigger looming business risk, from my opinion, around like not focusing enough around integrity, authenticity, and control of the data.
That example is really interesting, man. If for 2 years a model's been polluted, think about how much investment a company has put into like building up that model, right? Whatever number of GPUs went into training it, whatever, all of that can't be unrolled anymore, right? It is part of the thing you trained and spend a lot of compute and storage training for 2 years, and all of that becomes sort of a wasted investment, or worse, results that impact the reliability of whatever you tried to do with it, right? So there's that, but there's also like immediate strategic bad things that can happen, right? So if the messages are being actively tampered and there's an attacker somewhere in your environment, they can selectively tamper messages that are supposed to indicate actions of various kinds, like, I don't know, delete a database or spin up a bunch of instances. Like all of those are pieces of data. If they don't have guarantees around authenticity and integrity, they can cause action.
All right, so let's unpack this one. I don't need encryption, maybe because I don't care about privacy or security or whatever it might be. And then we'll do the flip side of it, which is, yeah, but I encrypted everything. I'm good. So who wants to start with I don't need to encrypt my data?
I think I don't need to encrypt my data usually is coming from a place of, I don't think my data needs to be private or secret. But it's never coming from a place of, I don't care if my data is correct, right? So people care about the correctness of this information. They just don't, maybe their use case is such that the information is some public observation of some publicly accessible piece of information. And so they don't maybe care about keeping it secret. But if you care about the data integrity of it, well, it turns out the mechanisms to have the privacy guarantee and also have the integrity and authenticity guarantees, those mechanisms just work together. So in Occam's case, Occam secure channels kind of provide that holistic guarantee together. And it's more expensive and often less secure if you try to decouple these properties. So they come as a package. You get data integrity, authenticity, and confidentiality as a package. And so when people are saying we don't want encryption, what they're really saying is it's okay if my data isn't kept secret or private, but they're not saying my data should not have data integrity and authenticity. And since they care about that, they need encryption because that's the way to get a guarantee of data integrity and authenticity. If I had to define security, in my mind, security is defined from the perspective of whoever's controlling a certain thing, right? Whoever is responsible for a certain asset. Let's say I'm the person responsible for making sure the data stored in that AI database is always correct. If that's my responsibility, I need to have control over who gets to store data in my database. What do they get to store, right? And so that control can only come from me having the ability to know who sent me a piece of information and whether what they sent me is exactly what they sent or was it tampered along the path, right? So you very quickly get to this I need control over the behavior of my system, what information is stored in it, etc. To have that control, I need authenticity of who is sending me requests and who am I sending responses to. And I need an integrity guarantee on what the requests and responses are. And well, if I'm all the way here, and since end-to-end encryption kind of brings all of these properties as a whole, I also get privacy. And in some cases, I care about privacy. In other cases, I might not. But if I need my system to be secure, I need a tool that will bring these properties, and they tend to come as a package.
Well, so let's take the other half of this, which is my data is encrypted. I'm good. Are you? That seems like a trap, and we've seen it be a trap. I'll kick this one off, but the question is, where are we talking about data at rest in your database while it's moving? Are you just talking about one TLS connection? Like this, there's a lot to unpack when people go into this false narrative that I use this tool called encryption, therefore I get security and my data is private. Do one of you want to tackle maybe Glenn, why don't you take on, I have encryption, I'm good.
Yeah, and I think the TLS one's an easy one to pick into because it almost feels like people have been given a checklist of stuff to go through. It's like tick, tick, tick. Like we've got encryption in transit, we've got encryption at rest, job done, right? And it's like the transit one, let's talk about that. Like I used the CDN as an example before. And it's cool, we've got a TLS connection from my desktop here to a POP in Melbourne. That's actually what you've got there. What happens behind the scenes? Well, shared responsibility model, we'll go speak to the vendor and look at their SOC 2 and we'll look at all these compliance reports and guarantee that that's been audited. But it's like anything in that supply chain there gets compromised and you don't know what has potentially been exposed. Like you haven't got control. It reminds me of that meme that used to go around of who's responsible for availability of your systems. And it was just a web page that just said you. It's always you. Even when you outsource it to a cloud vendor, ultimately you're the one that's on the line for. And it's the same with security, privacy, whichever verb you want to put in here. It's you at the end of the day, and you can have shared responsibility for it. But I think the easiest way to solve this is just there are the ends of the system that you can control, and if you can control both of those ends of the systems, you can build solutions that are secure all the way through, no matter what that supply chain looks like, no matter what the network or the topology is. You can build highly trustful systems in that environment. Same with anything that's sort of managed service of any sort, like a message queue or a bus. Most of them are designed intentionally to like have the data available plain text through that system. It's not just a pipe. They're trying to extend those, provide analytics, build tooling around that. Like the business in a lot of those cases is to have that data be plain text and visible there. Like that's not what you want. You want integrity and control and privacy all the way through your system. And so, you can tick a box and say, we've got TLS termination to the thing, and then we're just going to like cover our ears and eyes and ignore the fact that it's plain text in this really important, high value moment. And then it's encrypted again on the way back out. Really? It's not private.
This is probably a podcast in itself, but I think to play back the conversations we have when we're talking about other people's architectures and people talk about encryption, probably the first thing we jump to is, well, okay, tell me about the keys. Like, how and where were they created? How are they distributed? I mean, let's go back to our example before of like privacy. Like if you're generating symmetric keys for your encryption and just sending them out into the world or building them into software, and then you're calling that encryption. Well, now tell me, like, now you have this whole vulnerability surface around just how the key was created and how it was distributed.
If someone's building a system and all the participants in the system have one key that stays the same forever, and you call an AES function in some library to then encrypt using that one key, you effectively have no encryption. It might feel like it, but it's not, right? So calling AES is not encryption. Encryption needs to be end-to-end, and it needs to have a whole series of properties that I think at this point have been studied for like 30-ish years. And there's a ton of mistakes that can be made along the way. So you have to think about a rotation of keys. There's a bunch of work around like ratcheting them, getting forward secrecy type properties, getting properties that prevent impersonation, replay attacks. It's a whole host of problems that come with managing keys well. Obviously, a single key everywhere is not the answer, but even it's easy to also convince yourself you did just enough and you did it right. But there's so many CVEs in the history of secure channel designs that are all about, we thought we did it correctly, but then made a mistake. So that's why now a lot of these properties are proven using formal models. Like, for example, in Ockam secure channel design, we have formal proofs of various properties in our design. So there's a lot that goes into doing key management well.
Yeah, it is definitely the first question that gets asked after encrypted. You really haven't even said anything. You said the data's encrypted. Like, it's just now we have to have a whole conversation about what we're even talking about at this point, right? So I think we can just throw that one away as, well, you may have done some things well, but that doesn't actually mean you have security, privacy, integrity, authenticity. Like all these things go together, and having built entire architecture that has this secure by design, low vulnerability surface using proven techniques becomes really important. It's frankly pretty difficult to do ad hoc. And with that, I'll wrap up this podcast. That was a little insight into some of the things that the three of us talk about kind of when we're debriefing customer and I guess other podcast calls or kind of kick around. Hopefully that was helpful. And if you have ideas or we mentioned something in this podcast that you want us to dig deeper into in the next podcast, I think we've already identified keys and what goes on with keys. That's definitely a podcast in itself. And we'll definitely have to get into how we've built all of this at Ockam, because that in itself is a great story. So more to come, and we'll see you later.